Today we're going to look at decimals and fractions. So the first thing we're going to be looking at is something called terminating decimals. Now I've been using these a lot and you're familiar with them. These are decimals that, for example, 0.32. It's got a finite number of digits. Now these can be easily put in terms of a fraction. So we would do 32 over 100. And if we can simplify that down, that would be dividing the top and the bottom by 2. That would be 16 over 50. That is a terminating fraction, and we can take any fraction like that. So say we had 0.4, that would 40 over 100, or 4 over 10, which is 2/5. So we've taken a decimal and written it as a fraction. The other kind of fraction is the other kind of decimal is called a recurring decimal. Now these are decimals that don't have a finite number of decimal places, but they settle into a pattern of digits that repeats itself indefinitely. So say we have 0.316, 316, 316, 316, and that goes on and on and on and on indefinitely. The way that we would write this, so we're not having to write lots and lots of digits, is 0.316, and we put a point above the first number in the recurring pattern and the final number in the recurring pattern. These two dots tell us that the 316 is going to repeat. Say we had a decimal that was like this. So it's the same digit and it continues to repeat indefinitely. You would write 0.4 and then you'd put the dot above the 4, because there's only one digit within that pattern. Now, recurring decimals can also be written as fractions. Now the way to do this is, say we've got our example again of 0.4, and the dot over there tells us it's going to be a recurring fraction. So let's let x, get this number called x, be equal to 0.4 with a dot. Now multiply both sides of the equation by 10. So we'll have 10x, and if we multiply 0.4 by x, we're going to have 4.4. Remember 0.4 dot is 0.4444. So when we multiply it by 10, there's always going to be another 4 to take its place. And now we take this statement here that we've got and we write it underneath our 10x equals 4.4. So x equals 0.4 4 dot. Now subtract. So we're going to take 10x minus x and the 4.4 recurring minus 0.4 recurring. So we'll end up with 9x equal to 4. Because all those 4s in that big long line that goes on forever have just cancelled each other out. And then x is going to be 4 over 9. It's quite a nifty wee trick, so we'll do it again. This time we're going to have 0. We're going to wait a minute. What we'll do is we'll do it with 2.396. So again, just to remember, that means 396. 396. Oops, wrong way round. 396. 396. Keeps on going. Okay, just so this time we're going to let x be equal to 0.396. Multiply by 10. So we've got our 10x equals, oh, this time we're going to multiply by 1000 because we've got 3 decimal places, sorry. So this will take the 396 here. We've still got our dot, 396. Subtract. Our x is 0.396. So x is going to be 999 396 because the recurring decimal bit is cancelled out. So x is going to be 396 over 999, and we can cancel that down, so we'll, if you see, they're going to both be in the 3 times table, so you can cancel by 3, and then you keep cancelling down until we get to 44 over 111. But remember, we had this whole number here, so 2.396 recurring, we need to put that whole number back in. It's going to be 2, the whole number, with the fraction 44 over 111. So I hope that is clear, and that is all we're doing for this lesson.